Satellite communication basics. Satellite communications is an extension of LOS microwave technology. The satellite must be within line of sight of each participating Earth terminal. We are more concerned about noise in satellite communication links than we were with LOS microwave. In most cases, received signals will be of a much lower level. On satellite systems operating below 10 GHz, very little link margin is required. There is no fading, as experienced with LOS microwave. The discussion here only deals with geostationary orbit communication satellites. Satellite communications present another method of extending the digital network. These digital trunks may be used as any other digital trunks for telephony, data, the internet, facsimile, and video. However, fiber optics has become a strong competitor of satellite communications. Only very small aperture terminal systems are showing any real growth in the geo arena. A new type of communication satellite is being fielded. Satellite communication is nothing more than LOS microwave using one or two satellites located at great distances from the terminal Earth stations. Because of the distance involved, consider the slant range from the Earth station to the satellite to be the same as the satellite altitude above the equator. This would be true if the antenna were pointing at zenith to the satellite. Distance increases as the pointing angle to the satellite decreases. We thus are dealing with very long distances. The time required to traverse these distances, namely, Earth station to satellite to another Earth station, is on the order of 250 milliseconds. Round-trip delay will be 2 times 250 or 500 milliseconds. These propagation times are much greater than those encountered in conventional terrestrial systems. So, one major problem is propagation time and resulting echo on telephone circuits. It influences certain data circuits in a delay to reply for block or packet transmission systems, and requires careful selection of telephone signaling systems, or call setup time may become excessive. Naturally, there are far greater losses. For LOS microwave, we encounter free space losses, possibly as high as 145 decibels. In the case of a satellite with a range of 22,300 miles, operating on 4.2 GHz, the free space loss is 196 decibels, and at 6 GHz, 199 decibels. At 14 GHz, the loss is about 207 decibels. This presents no insurmountable problem from Earth to satellite, where comparatively high power transmitters and very high gain antennas may be used. On the contrary, from satellite to Earth, the link is power limited for two reasons: one, in bands shared with terrestrial services, such as the popular 4 GHz band, to ensure non-interference with those services, and, two, in the satellite itself, which can derive power only from solar cells. It takes a great number of solar cells to produce the RF power necessary, thus the downlink from satellite to Earth is critical, and received signal levels will be much lower than on comparative radio links, as low as -150 dBW. A third problem is crowding. The equatorial orbit is filling with geostationary satellites. Radio frequency interference from one satellite system to another is increasing. This is particularly true for systems employing smaller antennas at Earth stations, with their inherent wider beam widths. It all boils down to a frequent congestion of emitters. Frequency bands, the most desirable. The most desirable frequency bands for commercial satellite communication are in the spectrum 1000 to 10,000 MHz. These bands are 3,700 to 4,200 MHz, satellite to Earth or downlink, 5,925 to 6,425 MHz, Earth to satellite or uplink, 7,250 to 7,750 MHz, downlink, 7,900 to 8,400 MHz, uplink. These bands are preferred by design engineers, for the following primary reasons. Less atmospheric absorption, than higher frequencies. Rainfall loss, not a concern. Less noise, both galactic and man-made. Well-developed technology. Less free space loss, compared with the higher frequencies. If you want to learn more about networking concepts and definitions, don't forget to press the subscribe button. To be notified when our channel releases another video, click also on the bell icon. And don't forget to visit our website, networkencyclopedia.com.